Given that the third and sixth terms of a geometric progression are 3 over 4 and 3 over 32 respectively, find the first term and the common ratio. So now, if you see this, it means that there's another question. So let's just look at another question and see, okay? It's asking us to find the nth term, and then the other one is asking us to find the sum to infinity of the progression. So for us to find the first term and the common ratio, we need to use what we've been given. We are given the third term. Now, in a general way, the third term is a r to the power 2. And we are told this is equal to 3 over 4. Now, somebody would ask, but then how did you come up with a 2? Okay. The general term that we have for a geometric progression is given as an is equal to a, which is the first term, then r to the power n minus 1. So meaning that if we say the third term, this n will be 3, and then a multiplied by r to the power 3 minus 1, which will now give us a r to the power what? 2. And so it is less by 1 according to the term. So that's how we have known that this is the thing. So using this knowledge, the sixth term a to the power 5 is equal to 3 over 32. So we are going to use these two. A times r to the power 2 is equal to 3 over 4. And we are also given a times r to the power 5 is equal to 3 over 32. Now, using the knowledge of indices, we can split this and it can be written as a to the power, we use the 2 here, 2 times r to the power 3 and is equal to 3 over 32. Somebody might ask, but will that work? Yes. Multiplication of the same number with the same base, we simply add the powers. So 2 plus 3 will still give us 5. Now, since we know what this is, it is this one here. We replace it there. So 3 over 4 multiplied by r to the power 3 is equal to 3 over 32. So we need to get rid of this. So we multiply throughout by 4 over 3. So 4 over 3 multiplied by 3 over 4 times r cubed is equal to 4 over 3 times 3 over 32. So the 4 there, the 4 will divide, the 3 will divide, we remain with 3, that is equal to, here the 3 and the 3 will divide, the 4 also divide with 32, it's 8. So the answer is 1 over 8. Then we find the cube root of both sides. And we find that our cube root is 1 over 2. That is our solution. So in this question, we found the common ratio. We now need to find the first term. There is no order in which you do it. Remember that. So to find the first term, we are going to use this. Remember, we are given a squared is equal to 3 over 4. But we've just calculated our a, our r to be 1 over 2. So we substitute it there. So we have a multiplied by 1 over 2 squared is equal to 3 over 4. Okay. And so 1 over 2 squared is the same as 1 over 4. This is equal to 3 over 4. Then to find our a, we multiply throughout by 4. So 4 times a times 1 over 4 is equal to 4 times 3 over 4. And so this 4 here and that 4 will divide. Okay, so we'll have 1 times a, it's a, is equal to this 4 and that 4 will divide, and we'll have 3. So this is our first term. So this is our a value that we've just calculated. Let's look at now the next question. The question says the nth term. So remember that what we call the general term is ar to the power n minus 1. But then we always write it as a n is equal to a r to the power n minus 1. In our calculation, we have already calculated our a is equal to 3. We have calculated our r is 1 over 2. So when we substitute these values, we're going to find our general term or nth term being 3 multiplied by r is 1 over 2 everything to the power n minus 1. Okay. Remember that n minus 1 is with this value. But here is a situation. When you raise 1 to the power 2, the answer is 1. If you raise 1 to the power 100, the answer will still be 1. Meaning that even if I raise 1 to the power n, the answer will still be 1. Okay? And so this means that on the power here, on the 1 here, it will still be 3 multiplied by 1 over this 2 will be 2 to the power n minus 1. Then when we multiply with that 3, we get our answer to be 3 over 2 to the power n minus 1. And this is our nth term or our formula. The other question is to find the sum to infinity. Now, the formula sum to infinity is like that, which is equal to a over 1 minus r. Usually we find the sum to infinity when r is less than 1. What is our a value? Our a value is 3 and our r is half. So sum to infinity is equal to 3 over 1 minus half. Okay, which is 3 over 1 minus half is half. And when we're dividing a number by fraction, it's the same as saying 3 times the denominator of the fraction divided by 1, which gives us 6. And so we are saying, therefore, that the sum to infinity of this progression is 6. That is our solution.